Now, in this section, we will discuss about modulation and demodulation of signals. So, several signals out of different types of signals which are generally used for communication systems have frequency spectrum that is not suitable for direct transmission, especially when atmosphere is used as transmission channel. In such cases, the frequency spectrum of signal may be translated by modulating high frequency carrier wave with signals. So in order to transmit and receive the intelligent successfully, the processes called as modulation and demodulation are used. So now let us discuss about what you mean by modulation and demodulation. So let us first discuss about modulation. So modulation can be defined in different ways. So here different ways of defining modulation is mentioned. The first way of definition is modulation is the process of combining the low frequency signal with a very high frequency radio wave called carrier wave. The resultant wave is called as modulated carrier wave. Modulation may also be defined as a process in electronic circuits by which the characteristics of one waveform, that is carrier waveform, is modified by the variations in the another waveform, which is audio signal. And in detail, a modulation is defined here. Modulation is the process of combining an audio frequency signal, that is AF signal, with a radio frequency, that is RF signal, that is RF carrier wave. Now AF signal is called a modulating wave. As shown in this block diagram, this is audio frequency signal which is to be modulated, and this AF signal is called as a modulating wave. And the resultant wave produced after modulating, the resultant wave produced is called as modulated wave. During modulation, some characteristics of this carrier wave is varied in time with modulating signal, and it is accomplished by combining these two signals, that is AF signal and RF signals. Now let us see the need of modulation. What is the necessity of modulating the transmitting signal? The very important necessity of modulation is modulation increases operating range. So modulation also reduces the size of transmitting and receiving antennas. It permits transmission without wire, and it is extremely difficult to radiate low frequency signals through Earth's atmosphere in the form of electromagnetic energy. That is why suppose if low frequency signal is to be transmitted through atmosphere, then it is mixed with high frequency signals, that is it is modulated with high frequency carrier wave, and then it is transmitted through Earth's atmosphere. Now let us discuss about methods of modulation. So for sinusoidal carrier wave, the mathematical expression is given by E is equal to EC sin 2 pi fc t plus phi. So therefore, the sinusoidal carrier wave can be varied by varying one of the three variables, that is one of the three factors. Those are, first one, EC, the amplitude of the wave, FC, the frequency of the wave, and phi, the phase. So depending upon these three factors, there are three types of sine wave modulation techniques. Those are amplitude modulation, that is AM, frequency modulation, that is FM, and phase modulation, that is PM. So therefore, let us study these three modulation techniques in detail. So let us see first amplitude modulation. The process by which the amplitude of a carrier wave is varied in accordance with the modulating signal is called as amplitude modulation. So here the process of amplitude modulation is shown in these graphs. So this is AF signal which is to be transmitted. For the sake of simplicity, this AF signal has been assumed sinusoidal. And this is carrier wave. The carrier wave by which it is desired to transmit the AF signal is shown here. And this is the resultant wave which is called as modulated wave. The function of the modulation is to mix these two waves in such a way that the AF signal is transmitted along with carrier wave. But this amplitude modulation technique has got several limitations. Those are smaller operating range, poor efficiency, poor audio quality, and noise reception. Now let us discuss the second type of modulation technique is frequency modulation. So the process by which the frequency of a carrier wave is varied in accordance with the modulating signal is called as frequency modulation. So here the process of frequency modulation is shown in these graphs. The three waves are shown here. The first wave is the signal wave which is to be transmitted. The second one is the carrier wave, and the third one is the resultant frequency modulated wave. So here when a signal of frequency Fs is modulated with a carrier wave of frequency Fc, so a resultant modulated wave is produced here. So in this frequency modulation, the amplitude of the modulated wave is same as that of carrier wave, and the frequency of the modulated wave varies in accordance with the signal wave, that is the signal which is to be transmitted. So this frequency modulation technique also has certain advantages and disadvantages. The advantages are it has better audio quality, high transmission efficiency, and noiseless reception, unlike the amplitude modulation technique. But it has also got several limitations. Those are smaller area of reception, wider channel is required, and equipment used is more complex and costly as compared to amplitude modulation technique. Now let us see the third modulation technique is pulse modulation. Pulse modulation is a technique of modulating the analog signal and converting it into corresponding values. In this process, the instantaneous voltage of analog signal is sampled at regular intervals and transmitted during these sampling periods. So here in analog modulation, the amplitude or frequency or phase of a carrier wave is varied according to the instantaneous voltage of signal. But in case of pulse modulation technique, as we have defined, either amplitude or width or position of the pulse is varied according to the instantaneous voltage of signal. So now in case of pulse modulation technique, since the analog signal is sampled, so sampling rate is very important. So therefore the significance of sampling rate is given by sampling theorem. So this sampling theorem was developed by Nyquist, and it states that if sampling rate in any pulse modulating system exceeds twice the maximum signal frequency, then the original signal can be constructed at the receiver with minimum distortion. So here if FM is the maximum signal frequency, then sampling rate is greater than 2 FM according to the sampling theorem, and the minimum sampling rate is called the Nyquist rate here. Now let us see classification of pulse modulation. So pulse modulation technique is classified into two types: analog pulse modulation and digital pulse modulation. Again, analog pulse modulation is divided into two types, PAM and PTM. So PAM is pulse amplitude modulation. Here the amplitude of the pulse is varied. And this PTM is divided into two types, PDM or PWM and PPM. PDM is pulse duration modulation and PWM is pulse width modulation. In these pulse modulation techniques, we vary the width of the pulse, and PPM is pulse position modulation technique. So here position of the pulse is varied. Now digital pulse modulation technique is divided into two types, PCM and delta modulation. So this PCM is pulse code modulation and delta modulation.